So my name is Svetlana Isakova, and I work at JetBrains. And today I want to talk about the Kotlin programming language. So let's start our journey. Why another language? Why do we need one? Actually, technology nowadays evolves really fast, and languages are not exception. So nowadays we know how to express lots of different things, lots of different concepts, like in a more modern way, in a more convenient way to use to make code more readable, understandable, and easy to write. So Kotlin is a modern language. If you compare it, for example, with Swift from 2 hours developers, you will find a lot of similarities between two languages. And there's not a question of stealing one feature from another, the features from one another. It's more about the general knowledge how to express this concept nowadays in a convenient way. So what do I mean by modern? Kotlin is a concise language. I mean, you can you can express what you want to write in a more shorter way. So if you convert, for example, your Java program, your Java application into Kotlin, it will consist of less lines than your Java application. It's simply like that. What's more, it's expressive. It's in a sense that, okay, you may you may, for example, learn the language and during the way question, how should I express this concept in Kotlin? And after you find out, you think, oh, yeah, cool, that makes sense. But what do I mean by expressive is actually that you have more power to express your thoughts, to actually refactor and to abstract your ideas. You have more ways to, all of us don't like duplication in our code, and we always want to imagine some solutions to extract methods into libraries and so on. And Kotlin gives you more power doing it, for doing it. It's a safe language. I think you've heard about static analysis tools that can analyze your code statically and very often find some bugs for you. So, and now we know how it can be done, and actually we can do it in a language itself, in a compiler. So Kotlin compiler guards you better from your possible mistakes. So we want to solve some possible problems during the compilation time, not runtime. So we want to have some more warnings while we write code and to avoid fixing these problems later. We'll see in examples. So for me, that was very what all these modern languages have in common. They're concise, they're expressive, and they are safer than used to be. But what to some extent differs Kotlin from the others is that it's really a very pragmatic language. It's not from academia, it's from JetBrains. And we really need it we created to be used in industry, not just like scientific research project. What's important here? At first, Kotlin has a good tooling. So again, it's from JetBrains. It's the creator of Intellij Idea that now Android Studio is based on. So you can expect really good tooling for this language. And indeed, the Kotlin compiler that is written for Intellij works great for Android Studio. And if you use Kotlin, you have all this support, all these refactorings and completion and all the other cool features that are very convenient to be used in IDEs. What is another important thing that to some extent differs Kotlin from some other alternatives is that it can be easily mixed with Java code. And of course, if you use JVM language, it is often not a problem to call Java from this JVM language, because it just compiled to Java bytecode, and you can use Java methods. But what works for Kotlin is that you can really mix two languages in one project. For example, you can add new class written in Kotlin to your Java project and it will work. You can use Kotlin from Java code. Kotlin is designed especially to be used like this. And for example, now in Kotlin compiler, we have, I don't know, maybe half code written in Java and half in Kotlin. And it's not like some specific subsystems that are written in Kotlin. No, it's just from some time, we had started to add new classes in Kotlin and to change some old classes to Kotlin as well. So it's indeed they are indeed very easily mixed. So that was like a general introduction, and I want to show you more facts about Kotlin. First, it's open source, so if you want, you can contribute. It is compiled to Java bytecode. It is not designed specifically for Android. It's just designed to be able to invoke it as JVM language. And that means that it works greatly for Android, because Kotlin just compiled for class files. So Java compiler compiles Java classes, Kotlin compilers compiled Kotlin classes, but actually you can mix them together in one project, and then you can proceed with class files, compile them to special Android formats. Because we have a very one of our goals, as I told already, is to be easily mixed with Java code. And one of the ways to achieve this is that we don't have our collections library. So we use standard Java library. We just, to some extent, we just extend it. And that means that Kotlin runtime isn't very big. So it's like they're not a small library that you can add to your project, but it's doable. And ProGuard will erase lots of methods in it because you won't use everything. So this Kotlin runtime includes extensions to the libraries. So when you use not all of them, they are erased from the final jar, from the final build. It is very easy to start using Kotlin. There are special actions in IDEA and in Android Studio. We have automatic Java to Kotlin converter. So you can automatically convert your Java code into Kotlin and see what it looks like. Of course, this way you won't have always idiomatic Kotlin code, but at least it will work, and it is a good way to, like, if you don't remember how to or don't know how to express something in Kotlin, you can use the converter and see what's the result. So let's start with a live demo, and I'll show you at first how to start developing your application. So this main activity, actually, it was automatically generated by Android Studio for me when I just created a new project. You see, it's just usual Java code. And what you can do, you can convert this Java file to Kotlin, and it then should suggest, okay. You see, it's the Kotlin code, and it looks mostly similar to Java. Of course, there are some syntactic differences. For example, we use fun keyword to declare fun. So programming in Kotlin is lots of fun indeed. And we specify the types after the argument name, but not vice versa. It works for variable declarations and function declarations as well, because we specify function return type at the end of the function. So there are small syntactic differences, but generally the code looks very similar. Why not? I will show you another example of converter in work. There is a classical Java bin file, and in Kotlin it looks much more concise. When I convert it to Kotlin, yes, it looks like this. And actually it's the same beneath. It's the same logic. So it's in Kotlin we declare two properties, and the fields and getters and setters are generated beneath. And this concept is not like unique for Kotlin. If you look at some other modern JVM languages, you'll see something similar. So it's now we just know how to express this concept in a more concise way that is more readable. it's not a problem when you write this code. I hope that you use, I hope that you don't really write your getters and setters, you just generate them. But it matters when you decide to read code, to investigate what's going on. And for this situation, it's important to have as clear code as possible. And Kotlin helps you with it. Okay, so let's return to slides. And what now I'm going to talk to is safety. Safety in the sense of null pointer exception problems. So there is a classical problem that has its special name by Tony Hoare, $1 billion mistake, because no one can count how much money did it cost to fix all such problems. So imagine you have this very informative error message, and when you press the details, it becomes even more informative. And nowadays, what we want generally in these modern approaches is to make this problem compile time error, not runtime error. So we want to proceed with this problem during compilation phase. And it's, what I'll show you here is the concept of nullable types in Kotlin. If you followed Swift, they have very similar concept, very similar idea. Or if you have looked at other languages, they have different approaches to the same problem. For example, Scala has different approach to the same problem. But the problem still is rather important. So what do we have here is in Kotlin, you can declare the type, just the usual type that you declare in Kotlin, cannot contain null reference. So in a variable of string type, you can store only not null strings. And if you want to store null reference in this type, you have to declare it with question mark. That means nullable type. And what you can do and what you can't do with nullable types, let's see. Sorry. Yeah. So you have these nullable types, and you can dereference not nullable types without a problem, because there is no possible null pointer exception here in this first line. But when you try to dereference, simply dereference nullable type, you have an error. You have a compile time error. So Kotlin compiler doesn't allow you to dereference nullable types. And it forces you to check it explicitly. Of course, you can't do the same trick in Java. You can't just check every type for not null. But it's crazy. It will spoil your code. It would be impossible to read. Kotlin provides you concise ways to cope with this problem. So what you can do, you can check explicitly if it's not null, and in Kotlin, after that, you can dereference it safely. And even here, the compiler suggests me to replace this if expression with safe access expression. It looks like this, and what it means, if I'm not mistaken, this feature was stolen from Groovy or something. And what it means is that if S2 is null, then return null as a result, the whole result. So it is very useful to make such chain calls with question marks. What we have, okay, I think I'll show you. What we can do next, this expression has, the result of this expression is just int, is not nullable type. But if you access nullable type with question mark, the result type is int question mark. So it can contain null, obviously. What you can do as well, you can provide default value for it. So if this expression is null, then the result is 0. If you want, you can throw null pointer expression explicitly. Interestingly, in Swift, they have, as I've told already, they have similar notation, but they have one exclamation mark for dereference for not null. In Kotlin, we have two, just try not to use it. But anyway, the idea is that if you write it explicitly and you have null pointer exception later, it is easier to see where it was thrown. You can check, this fail function actually throws an exception, and if you check, then you can dereference it safely again. So in Kotlin, there is quite a sophisticated logic for these nullability checks. So the idea is that you have to check always for being not null reference, but you have easy ways to do it. Okay, this example. But let's move more to an Android. You see, imagine I have an activity and I want to store the property in activity. And the safe way to do it is to say, okay, it should be null reference because we have to initialize it with something. And actually, that's a kind of a problem because afterwards you have to dereference always this property as not nullable, but you may have some guarantees that it's not nullable, but you don't always have some initializer type for the case. So, and actually this was how we lived for, like, we fixed this issue, I think, mostly recently. Before there was a solution, but it was not so concise. But what you can do now is you can mark your variable as late init, and in this way you can specify its type as not nullable. And so Kotlin provides you some ways to cope with null pointer exception problems in a more frequent for frequent cases, for really for what we cope with every day. Okay, and another point what I wanted to mention is that it might be interesting how these nullable types are implemented beneath. Because do you have any overhead with it or not? What do you think? How it can be implemented? And actually, the answer is that, you see, we have these nullable types, and we could create, for example, a wrapper to store this nullable type. But in this case, if we created a wrapper, it would be overhead, because we should, at first there will be like tons of extra objects, and you have to live with it, to cope with it. But in Kotlin, it's not the case, and how it's implemented is with annotations. So you just annotate for example, if Kotlin function returns string question mark, nullable string, it is annotated as nullable, and that's how Kotlin checks everything. So there is no overhead to use these nullable types. That's important. And that's crucial for Android, because for Android it's more important that we don't have overhead in our application, in our language. Okay, let's continue with some Android examples. And I want to so that was all about the safety and tolerability. Maybe any questions about nullable types? Okay, let's move on. No, a question? Yeah, sorry. What do you say? Are they how we cope with primitives? Yeah, actually, the Kotlin compilers tries to be smart with regard of primitives, and whenever possible to convert int without question mark to int primitive and int with question mark to integer. Of course, it's not always possible. For example, if you have a collection of ints, it should be a collection of integers. But when it's possible, it converts to primitives. Yeah. Yeah.
When you put late in it, what would be the result if you try to reference that?
Yes, it would be a special exception that you try to dereference it and it's not initialized. Yeah, but the code, so you actually you have these null pointer exceptions in Kotlin if you, for example, have if you mark it explicitly with exclamation mark or with these latent properties. You have some special types of exceptions, but what is important here, they are more readable. They give you more information, and it's easier to cope with them. You don't have to investigate and trying to understand where was it thrown, what was the cause, and so on. So now let's look at the next example. It's an activity, and it's a very simple activity. It has only one button, click me button, and I show toast on click. What's interesting here is these curly braces. These curly braces actually means lambda. And I think you are familiar with lambdas. Who is familiar with lambdas to some extent? Other? Oh, almost everyone. Okay. Anyway, I'll explain you. But the thing is that in Kotlin we support lambdas. You can write your code in functional style, and it works perfectly with Java 6. So you don't have to wait for Java 8 to be able to use this functional programming approach. So this one is lambda. In Kotlin, lambda always goes in curly braces. And another interesting issue is that this setOnClick listener is just an Android function. It's not a special Kotlin function. It's just an Android API. And this method has a parameter, this interface with single abstract method. And in this case, you can pass lambda. In Kotlin, you can pass lambda to it. So you don't have to do something special just to use it. Okay, let's have a bit of lambda theory. So you can declare this anonymous function or function expression in your code and to use it later as a data. So you can store it in a variable, for example, and you can invoke it as a usual function like this, or you can here I have like list of people, or I can pass it to the other function. So if you show these convenient methods to work with collections, like filter, map, etc., you can do it in Kotlin. You can use this method. For example, this person's filter is adult. It just returns a list of only one person. And okay, yeah. If you have, so you can filter this. You can filter this list as before. So you can pass an expression to it, or you can pass a lambda. And what you can do next, you can then, for example, map this list of person to just list of names, like in this example. This example returns you a list of one element with a name. What you can do, I don't know, you can find maximum by some predicate. So here you can find the oldest person in your list. And in Kotlin we have this syntactic convention. I want to show you that if you have lambda as a last argument of your function invocation, you can omit these round brackets. So move lambda argument out of parentheses, and I had it. Okay. So these two lines actually means the same. It is just a syntactic convention. It is just a syntactic sugar for your function invocation. Please remember it. We'll use it at the end of the talk, this syntactic convention. And you can, in Kotlin, you can specify the name of the argument explicitly. So, for example, here you can say destination equal #set, and it's just a function invocation with a lambda. We'll again use it afterwards. Okay, but maybe remember that I told before that in Kotlin we don't have our own collections. We use standard library collections. We don't create our own. But how then it works? Because you see, in Java 6 or in Java, collection list doesn't have this filter method. But in Kotlin, we use this filter method. How? How is declared? In Kotlin, we have this concept of extension methods. Maybe you're familiar with the same concept in C#. Anyone? Okay, no C#. The idea is that you can extend a class with a method, like here, for example. Every project, I think, have this terrible list of util methods that improve your libraries, that add lots of methods that we want to have, but the class doesn't have it. In Kotlin gives you a nice way to declare such util methods. What's the way? Here, string is a Java length string. It's a library class, and we want to have last char method in it. What we can do, we can declare it in special syntax, like extension function, and in the body of this function, we use this as a reference to receiver, to string. And like this, usually, usually, you can omit this reference, like here, and have just this syntax. So remember, this can be omitted in Kotlin, and when it is a reference to this extension receiver. And why it's convenient? Actually, these extension methods, what's one major difference with C# approach is that you declare these extension functions, but you have to import it explicitly if you want to use it. So that means you always know where your extension functions come from. Because otherwise, it can be a problem to read the code and to understand where goes these extension functions. So I don't have this member, where it goes. But in Kotlin, because you have to import them explicitly, you always know what to expect, where it comes from. And these functions are visible in completion. So it is very convenient. For example, in this case, I saw this, my declared last char function. How we usually write code, we just, I don't know, how I write code. I invoke the completion and try to find out the appropriate method for me, for my case. And when you have this, it's like a common pattern. And when you have these extension methods that are visible from completion, they're easier to investigate. So it's easy, with these methods, it's easier to work with your API. Okay. As I told, Kotlin is very easily mixed, can be very easily mixed with Java code. And that works with extensions as well. And every Kotlin method can be easily invoked from Java. How it can be done in this case? Let's see. Actually, these extensions functions are compiled to just static functions in Java. That means you can't override them, and obviously in the body of this method you can't access any private members of a class. So it's just a way to add utility functions to your class. And when you use it in Java, you just use it as a usual extension, as a usual static method that has the receiver as the first argument. So here, our last char function converts to, we see that it's a static function that gets string as a receiver. So you can, and yes, there is a question.
What about return type in extension functions? You haven't explicitly marked one. So is it inferred or? Yeah,
in Kotlin, these types are, in Kotlin there is like type inference, and lots of types are inferred. If you omit one, it is inferred, and you can specify it explicitly, it's just char.
Okay.
So this, as you saw already, in Kotlin you can declare functions at the top level, And these functions becomes just static functions in your Java application. And they are put in actually in a class corresponding to file name, like here. And you can, in Java, it looks like normal Java. You can, for example, import it statically, and it looks like your usual Java util, your usual Java invocation of util classes. But in Kotlin, these extension functions looks and feels more like Kotlin. So they are visible in completion, they are reusable, and so on. Okay, let's return to our buttons activity. And now we understand where is this, what does it mean? It means just lambdas. And now let's simplify this very simple code more. At first, there is invocation of this toast function, and it can be simplified to just this. How it works? Of course, you can declare such function in Java as well, but you see there is this reference that somehow hidden in this invocation. And actually, what does this toast mean is it is an extension function on an activity. So these extension functions actually allow you to simplify your code, to make it, again, more readable and understandable. Okay, let's let's do something else. For example, you want to think this. Yes. There is an example when you want to start new activity. This is how you usually do it in Java. You just create an intent, you set some parameters, maybe you set some flags, and then you start an activity. In Kotlin, you can, again, there is some nice, oops. Yeah, in Kotlin, you can use nice utility function, for example, like this. And again, there is a flag, and this flag is again an extension function. Yeah, so we can simplify this code. We use extension functions, and it allows us to eliminate some verbosity of usual Java code, of the ceremony that we used to have. Now in Kotlin, it just looks a bit simpler with the help of extension functions. And if you don't, for example, if your activity doesn't have a flag, you can do like this. Sorry, new activity, and just specify its parameters. It's indeed a bit clearer. And why it works? Because of extension functions. Again, Kotlin, again, in Kotlin we don't have our own libraries, but we just provide a bunch of useful extensions that can help to simplify your usual code. And these two functions, these two words, keyword, actually, it's a function, and it is an extension function that allow you to write to invoke it in fixed notation. This one. So it's the same as calling with dot. It's the same syntax, but without it, it's more readable. But again, it's just an extension function on generic receiver. So we simplified a bit this code, and we can simplify it even more. Now goes my favorite part. You can, in Kotlin, write like this. And that's it. How it works. No. In Kotlin, there is a special plugin that is called Kotlin Android Extensions. And what it does, it allows you to call the the view that is mentioned in your XML by ID just by its ID, just by its name, like this. So if you somewhere in your XML file, XML layout, declare click me button with the ID in Kotlin activity, you just use it as click me button. It's an extension plugin for Kotlin. There are some thoughts of unifying it with Kotlin plugin, but nevertheless, that's a Gradle plugin for that you can use in your project. And what it secretly does, how it works. So you can use it, but you might be interested how actually it's implemented. Let's look at it. To some extent, what actually is going on here when you use this plugin is this one. You have, for every Kotlin activity in your project, there is a special cache generated that stores the values, the views, the map from IDs to views. It is nullable, so if you don't use this notation, then it's just null reference. It is initialized lazily if you invoke some of your IDs from your code. There is a special function, get cached view by ID, that works as expected. It just gets the view by actually beneath it invokes classical get view by ID and then caches it in this map. And on each invocation, the access for this function is generated beneath. So this code in blue is what is implicitly added to your Kotlin activity when you use this feature. Actually, there is no, this variable is not created, click me button, but it is in light. So this code becomes just cached view by ID and set on click listener, but for the purpose of presentation, we are okay with this idea. So the idea is, yes, you have the concise way to invoke these activities, and Kotlin does the rest. It adds a map to, because we compile the Kotlin code ourselves, so we can change it, and this can be implemented. So with some other language, it would be a bit more tricky. Okay. No, actually, it just the map field just added to your activity, and then when you use it, you invoke get view by ID, and you add it to your map. Yes, this code is generated. This code is generated for you.
Yeah. So how does Kotlin knows that my layout contains click me button and any other whatever?
So it reverses XML,
okay,
and generates. I'll show you. Yes.
Okay.
Now I'll show you this how it works. This click me button. Actually, in Kotlin we have these extension functions, as I've already shown you. But as well, we have extension properties, and actually it is declared like. Oh no, this. Actually, this was declared. This is declared as an extension property to an activity. We resolve this. In Kotlin, we resolve it this way. And what this extension property means is that the code that I've shown you in the previous slide was generated. Okay, I think, please ask me after the talk. Okay? These IDs actually store the type of your view. So if you have checkbox, you can access it as checkbox. So it's not a view; it's a view of the type declared in your XML. So it is indeed very useful. Okay, so now I have like very small time, but I want to show you a bit more of Kotlin and Kotlin approach with this very simple application. Yes, it just shows the difference. And Kotlin, you can declare this in XML layout, this activity, this code for this example. But what you can do in Kotlin, you can declare it dynamically. You can create your views in a dynamic manner. So, for example, if you have, if you want to add new location, it will be very convenient to just, for example, here Kotlin is actually the name of an island near St. Petersburg, and it can be implemented using using these dynamic layouts. What? Just a second. Yes, this one. So so you can imagine the XML file for this simple layout. It's like vertical layout, table layout, text row, text view, and so on. But in Kotlin, you can create it using Kotlin functions. And do you remember what I wanted you to memorize during the talk? Actually, this is lambda. And this is like calling an argument with a name. So text is a name, and Paris is a value. And what's this lambda as well? And it's not just a usual lambda. It's lambda. It's so-called extension lambda. Lambda with an implicit extension receiver. So actually, in this example, this is hidden beneath. So this approach is like a modern approach. It's controversial whether you want to use it like for all your, whether you want to rewrite all your XML layouts to this. It's like a new approach to express this. The benefits are that it's reusable, that you can extract, that it's just that it's statically typed and easily checked, and it's not an XML, but it's a code. And it's a bit faster because you don't have to use reflection to create all these views. But you have to teach designers to write your to draw your application in this style. How? But anyway, it can be very useful for simple for example simple alerts. I show you this assure alert, and the corresponding Kotlin code has a very clear there is a clear correspondence with this alert, so it is much readable. And again, this Kotlin code is just function notifications and lambdas in curly braces. The same thing, custom layouts. It can be very useful to create such layouts dynamically, and it's much more readable in a Kotlin way. Okay. I think, yeah. One last example. I've shown you this simple code when you create an intent. And what you can do in Kotlin, you can write the code like this. You can use with and just access, enumerate the method you want to call. I think this example should be very clear because it's a common structure. It is used in several different languages and so on. But what's interesting here is that, as I've told you, Kotlin is a very expressive language. It allows you to express lots of patterns and to express abstract ideas. And in Kotlin, with is a function. It's not a special language construct. It's just a function declared in your language, in the library. And here's how. I would say don't look at types. It's a new syntax. It might be difficult to understand, but what is going on here? We have a receiver and we have a function that can be invoked on this receiver. And in the body of this function, we just invoke this function on the receiver. And there is how these types are written in Kotlin. So the idea is that in Kotlin, with is a function. And and there are lots of other similar concepts that can be expressed in the language. They don't have to. We don't have to invent or implement some special language constructs. We can just use it as functions. And in this example, when you use with, this in this blue square is just a lambda. Again, this lambda is lambda body, and this is an implicit receiver in this lambda. So Kotlin is expressive language indeed. Okay, so I think my time is over. I wanted to mention another thing. This with function is declared as inline, and it is important for, we saw in the beginning of the talk, this filter example, filter map, and so on. And you can imagine that if you create all these lambdas in your code, it would be a disaster for Android, because how these lambdas are implemented. If they implemented as an anonymous Java classes, it would be a huge performance drawback. But that's not the case. We don't implement, for many use cases, when you can declare these simple functions as inline functions, and this inline means that actual lambda will be inlined. So the final code won't create this extra object. It would just inline all the method body, and it will be simply like this. Okay, so now I'm over. There are some links and what you can do with Kotlin. So there is our site, and now Kotlin is released in beta version. And we plan to release a 1.0 version very soon. That means, and we guarantee backward compatibility for the language after this, because before this we made changes very fast, and during the last year. So those who used Kotlin, they have to live with all these changes. We provide the ways to go to the new version, but anyway, it provides enough documentation for everything, and we have the way to learn Kotlin syntax online. We have a Try Kotlin lang site that allows you to play with Kotlin, and we have Koans, Kotlin Koans. We have them online as well, so you can, if you want to get familiar with Kotlin, you can just implement these tasks. And there are 42 tasks that should be done. And after that, you can tweet about it as well. And there is another way. Another thing I wanted to mention. It's now we are writing a book about Kotlin. It's not completed, but again, if you're interested in the internal details of how everything is implemented, you can be interested in the book as well. And there is a discount code. It's on the site, so you don't have to now to write it down. So, thank you.